Hi! In this session we're going to talk about starting your automation journey. My name is Alexey Grinevich. I work in IT for last 20 years and I work with Rapise from its very beginning 11 years ago. If you have any questions during or after this session, please use the chat window for this topic. Despite of the fact that we keep saying that automation is not just about recording and playback, we see that users simply try this approach as their first step in their automation journey. So let us do the same and let us try to record a script in Rapise. Here we have our application under test. It's simple book management system. Let's launch Rapise. Create new test. Book management test. It would be web application. I'm using Google Chrome. Use Rapise Visual Language and start recording. Recorder starts. Application is on the screen. So we are just doing some simple scenario, including login, passing username, password, doing login, and doing logout. Finish. Recording is done. Let's see what we have. It asks where to insert recorded steps. We insert it in the beginning. And this is our testing script. So easy peasy, we have working test script. We may execute it, we may change browser, so it looks like we may do some automation at this stage. So do we have automation script now? Let's have a look. Yeah, it is an automation script. It has objects that were recognized during recording, such as login button, password, username. It has data in separate column that may be modified, but the whole automation usually means many other things. For example, we need to take this data from some database or from some spreadsheet and feed into this application. We want to change browsers. So here we have a list of browsers, we may switch between them, and ideally, in the end, we want to execute this script for all browsers. So the whole automation means many additional steps to have final test framework that really tests your application. The piece we just recorded is login logic. And this is what most of people do when they start doing some scripting. And it is easy on the demo application, while in real life the logins may be really tricky. And let me explain why. If we look at our login screen of this demo application, it's quite trivial and it's always the same. When you press login, you always get this username, password and login button. In the reality, in most cases, we deal with the system with some integrated login logic. It may be Microsoft Live login, it may be Google login, it may be Okta login. And these logins are really sophisticated, and the screen that we see right now may be really different. We may enter application and just see application itself, so it may be skipped because your credentials are remembered. From time to time, it may ask you to enter password. From time to time, it may ask you to enter username and password. Sometimes it requires two-factor authentication and sends you confirmation somewhere, or shows you some kind of captcha or reCAPTCHA. So this login has several different behaviors, and whole scenario doing login may be much more sophisticated than other scenarios in your test set. The strong feature of Rapise is if you have troubles with some module, for example, you have troubles automating login, you may skip it. Let's look at the example. Here we have medical application, and in this case I have it open and already logged in as a nurse, and I'm going to write a test that is collecting vitals for one of the patients. For some reason, let's suppose I have troubles doing login, it's too tricky, or it's not yet complete, or development team is not yet decide what kind of login to use, so it's temporary and it will change. So my goal is to write automated tests that is not touching login at all for now. I have a new test, it has nothing yet, so I just hit record, and I'm doing recording to this application where it just logged in and shows some kind of dashboard. So my goal is to capture vitals. I click here, I select the patient I was going to collect vitals for, record vitals. I'm going to enter weight. Suppose we are measuring weight for this patient like every week or every day, and save it, confirm, and return to home page. So just hitting finish. You see, the important thing is that I finished at the place where I started. So this way I may execute it time after time. And I attached the browser in already logged in state. I recorded a script, let me append it. Here is my script, here is vitals value, I may change it for execution, and I may just play it. Rapise will attach to the same instance of browser and execute my script. This doesn't mean you don't need login at all. At some point in time you will need to have it implemented to have tests running end-to-end. In the intermediate stage, if you are just learning automation, you're doing partial automation, or you know that some piece of application will change, you may use this approach. So skip tricky part and leave it for later. This is really good practice for doing automation. So you see my test passed, everything is green. So I automated a part of application and skipped a tricky part for now. Many of the problems are not unique and already resolved by someone else. We try to publish all reusable things at our Inflectra resources and maintain them with growing set of updated snippets and explanations. First is official Rapise documentation page. You may find it at rapisedoc.inflectra.com. It contains organized official documentation of Rapise. Next common reusable thing is knowledge base. You may find it here by pressing KB menu at Rapise documentation menu. Contains a lot of topics covering many particular common and uncommon situations that you may have. One more such resource is Inflectra GitHub. I'm just googling for it and it will be the first result found. And an example of how I may reuse it is the following. Suppose that the test I've just recorded uses Microsoft Online login. So I want to find such login already implemented by someone else and simply use it in my test to not spend time on implementing my own universal login. What I may do, I may filter this Inflectra GitHub repository by the number 365 because it's common postfix for Microsoft products. And a good example here is Dynamics CRM. And here in this piece, I know we have a function login Microsoft Online. I'm going to simply copy it and paste into the user.js of my test. So this is JavaScript function implementing optimized, polished login procedure for Microsoft Online. So now, if I know that my test is going to use Microsoft login, then I may simply use this new function instead of recording this logic. I may use the functions object that contains login Microsoft Online. And here I just need to fill username, URL to the application, username and password. So adding this step will enable this kind of login. This is all what I need to do. I just reused common logic and I reuse experience and the efforts already put by someone else into solving this problem. I may find similar snippets for different other types of application. For example, for basic authentication, for Salesforce, and so on. It's already available either in GitHub or in knowledge base. When you are new to something, there are two ways to start learning it. First is just start trying and then learn while you go. Another is to study theory behind the topic. Let's talk about some theory behind testing automation. Testing efforts is total human time spent on testing, and it's a perfect way of measuring testing efficiency. If we consider efforts required to do testing of the application, in case of manual tests, we know that execution of whole test set manually requires some specific time, and it is done for each release or for each cycle in the application. So the graph of efforts is close to straight line. It may vary a bit, but it's looking overall like that. In case of testing automation, from the beginning we have to spend additional amount of time to record or to write test scripts, to make them data-driven, to make test frameworks, to do some additional things, to do preparational tasks, and to have all testing-related scripts well developed. After that, the efforts to write tests goes down because we have working test set, and all our efforts that we are spending is some time required to maintain this test set. Maintaining means fixing some test cases when application changes and we have to change some tests to reflect this change. Or when it finds a crash, we need to figure out what kind of crash is that. Is that a problem in application or is that a problem in the test? So this is happening. Or some environment changes like new browser version. For some reason, it doesn't, tests are not running on this browser version. We need to figure out how to quickly fix it and run the test. So this is maintenance cost. In the long run, it is expected that there is some difference between manual and automated test execution. And this is an economy that is growing with time on the long run. This is why we should have these automation tests. So this is an ideal picture. But due to some technical decision, these things may get worse. For example, it may look not like that, but like that. if we implemented test cases badly or made some wrong choices and maintenance required more efforts than even manual test execution, or its application is changing so quickly and so deeply that we have to rewrite a significant amount of test cases, this graph may look like that. So instead of economy, we are getting losses, because it's really hard to maintain this kind of automation. And in some cases, due to some decisions made, it may even look like that. So it may grow with time. This also happening if test cases are too complicated, it's too hard to figure out what are they doing. They're breaking too often, they are badly designed, and some strange or illogical things were implemented instead of simpler and more maintainable solution. So the difference between these approaches is, first, application maturity, and second is maintainability of test cases. So we believe that you should focus on this side when you're choosing between a technology. And good technology should have good maintainability, so you have this saving instead of this loss in the long run. We think there are three key factors that drive efficiency of final automated testing solution. First of them is ecosystem or technology stack you have. For example, if you develop for Microsoft Dynamics, probably you already have Visual Studio, TFS, Azure DevOps, all of these or some of them already used in your development process. If you develop for Android, probably you have either Eclipse or IntelliJ inside your organization. You may have some project management tools of choice like Jira. So, when applying automated testing solution, you need it to fit into your ecosystem or into technology stack. And this is one of the strong points of Inflectra tools as a whole. When we talk about Inflectra tools, we mean Spira set of tools, Rapise and Chronodesk. For example, for Spira, in this case, for example, Spira Plan, on its site you may find the section Integrations. And here it lists both short overview of different types of integrations that Spira has. And you may click on add-ons here. Here in the add-ons section you may see impressive list of different kind of extensions and add-ons. So most probably whatever you currently have in your ecosystem or in technology stack, you will be able to integrate with that. When it comes to Rapise, if we look at its documentation page, we also may find hints on integration. In this case, integration usually means integration with Jenkins, execution from continuous integration tools. So here it's easy, you may search for Jenkins on this site and you will find the tip on how to enable execution of Rapise tests from Jenkins. You may look for TFS if you use Microsoft Technology Stack, and you will find corresponding manual. You may search for DevOps and you will find manuals for Azure DevOps and DevOps pipelines. So Rapise is as open as possible and you may use it in different situations for implementing and executing automation tests. Next factor is learning curve required to start using some automation technologies. We've shown you today how you may do some basic scripts by using just recording. Now let me show you how to improve it, for example, make it data-driven using Rapise. Here is the test script we recorded earlier today. I want to make it data-driven. I wanted to take several values for the weight and feed them into the system one after another. And that's really an easy thing with Rapise. What I'm going to use is the map built-in feature of unveil. The map will be called, for example, weights. It would have just one column, so I'm removing redundant things. Column will be weight and put in some value. For example, 90, 91, add few more rows, 89, 90. So it's more or less random values we're going to feed into the system for some reason. Once we have this data defined, and you see that unveil enables defining that data right here, we may simply use it as follows. For the place where we enter the value, we change the type from string to weights, to the name of the map, and then specify column from where to take the values. So when running this script, it would take value from this cell. It would take 90. Now, if I want to iterate, it's also really easy with Rapise. I may wrap this whole piece of logic into a loop statement. And as loop type, I'm going to use map, go through map values. Now I need to specify map name, and map name is weights. And that's it. You may notice that I only used mouse to implement this script, except typing these weight values where I needed some keyboard inputs. So now I have a data-driven test. And as we discussed earlier, in the long run, the key factor that defines the efficiency of the automated testing solution is maintainability. This means how much time you spend on updating the tests or fixing them during the application lifetime. Here we can see an automated script. I intentionally broke this test by making change to the object capture vitals location and making some improper value here, so it cannot be located on the screen. So my intention to emulate situation when this test is broken and to show you how to do in this situation with Rapise. First of all, now I play this test. So I'm executing this logic, and what I know is that it should fail because the object capture vitals will not be found, although you may see it is on the screen. In a while, we see failure report available on the screen, and it's saying that object capture vitals is not found. So here what I can do, I may try to find it manually using the flash command, just to make sure that the issue is due to the fact that locator is incorrect. Sometimes this happens just because object is not yet on the screen. So I'm flashing to make sure that object is on the screen and it's anyway not found, so locator is incorrect. Now I'm going to quickly fix this. Since it's on the screen, I may use relearn feature. Just click on the object, do relearn. It says click on the object to be relearned, so I'm just clicking on this button again, and it's update the recognition. Now, since my piece of script is fixed, what I may see is that application stays in the place where it were when it failed. So I don't need to run this test from the beginning. What I'm going to do is just to first execute this statement that didn't work properly by using place selection. So if it works, I'm fine and I may proceed execution of my script, and it worked in this case. If it didn't work, I could change something with object definition and try the same statement again, and this is a great time saver because application is still running. I don't need to do, say, to launch a browser, to do login, to just try this piece. I only focusing on this piece. I'm trying it as many times as needed until it works as required. So now it worked. I may just proceed execution of my test case. I'm selecting the next statement in the tree and choosing play from here. Play this statement and all other statements up to the end of this script. You may see that execution passed. One more important thing to notice is that the logic that I was executing is actually nested. It's inside the loop. Anyway, with Rapise, you are able to execute pieces even from such nested statements. It's a unique feature of Rapise visual language, and its goal is to make it easier to work in situations just like we have right now. We may quickly and easily repair a statement and fix the test, even if it's some internal logic. This is a great time saver. This was demonstration of maintainability with Rapise, but it is not everything related to maintainability. Actually, the whole Rapise is built around maintainability. This includes many design decisions built into Rapise, starting from small installation package, so you may quickly deploy it somewhere and check your assumptions on the clean host. It also includes built-in Excel engine, so you may edit values for data-driven tests. It also includes Spice in special maintenance mode, where you may update a number of changed objects in just a few clicks. This also includes web app profile that improve the quality of recording and web libraries that enable high quality recording where your tests are resilient, and when application changes, they have much higher chances to just survive and keep working without any fixes to the tests. So all these together form the maintainability that is a focused feature built into Rapise. And we at Inflectra believe that in the long run, this would bring you the most benefits from automated testing in your organization. I'm Alexei from Team Rapise at Inflectra. Thank you for joining me today. And I hope you will enjoy the next session about framework for testing web applications with Rapise.